Hello, we are on video number 2 for solving right triangles, and this is section 10.3. We're using Trig to solve the right triangles. On this one it says find the angle M in the casting shown, round to the nearest tenth of a degree. So it's telling you where to round to. On this one, since we have fractions in the problem, that can be helpful. I am going to change those to decimals. So from angle M, we have the side opposite, and because this is our right angle, we have the hypotenuse. All right, so opposite over hypotenuse is sine. So we say the sine of M is equal to the opposite side, 2.25, over the hypotenuse, 3.25. To solve for M, we're going to take the inverse sine, so second sine, take 2.25 divided by 3.25, and then that's going to give you the angle measure. So remember, you press your second or shift depending on your calculator to get the sine. It should say sine to the -1 on your screen, and then type in 225 divided by 325, and we get 43.8 when we round it to the tenths place. And of course that is degrees. So 43.8 degrees. Here's our next example. A helicopter flying directly over a fishing boat at 1,200 feet spots an ocean liner at a 15-degree angle of depression. How far from the boat is the ocean liner? Now, the angle of depression is looking down from the helicopter to the boat, but we have a angle that corresponds to that that's also 15 degrees looking from the boat to the helicopter. And so in this case, it was easier to look from here to the helicopter, right? And then we can use that angle to calculate what we need, because we've got the 1200 that is opposite, right? Opposite that angle measure. And this goes back to parallel lines back in chapter 8 when we talked about when we have a transversal and the angles that are the same. So this angle of elevation and angle of depression are equal, and that's going to be the case each time. So what we have is the side opposite. We are looking for this length, right? On the water here, how far apart are the boat and the ocean liner? And that is the adjacent side. This is the opposite side. So we will be working with tangent. So the tangent of 15 is equal to the side opposite over the side adjacent. So we multiply by x on both sides. So x times the tangent of 15 equals 1200. Right, because we cancel that out. So basically, to solve for this, we divide 1200 by the tangent of 15. So x equals 1200. That is feet divided by the tangent of 15. Whoops. Calculate that. And on this one, if we round according to the measure that we were given, right, originally we get this if I just round it to a whole number, and then that would be 4,500 feet if we round it to two significant digits like the 1200 was. So 1200 is two significant digits because the zeros aren't significant. 4,500 is also two significant digits, and our angle measure was to the nearest degree, which goes with that. So that's how we want to round that. All right, next, construction. A road has a rise of 6 feet and 82 feet. What is the gradient angle of the road? This is a common thing for roads that you would be finding the angle of the road, right? How much is the rise versus the run? And on this one, our angle is the one we're looking for, which is down here. They've kind of got it pointed there. You know, it's super small, as you can see. And so opposite, and we've also got the adjacent side, right? This one. That will be tangent again. So let's call this A. The tangent of A is equal to, right, my opposite side over my adjacent side, because that's what we do with tangent. So A is equal to the inverse tangent of 6 divided by 82. And we find that that angle is 4 degrees. So we rounded to the nearest degree because the sides have 2 significant digits. So the nearest degree is going to be 4, and that's the reason. Let me write I never did write opposite and adjacent. Whoops. How about a D in there? All right. I'm going to write this out about the rounding part. Round to the nearest degree because sides have 2 significant digits. Now, if you're not sure where to round to and you're doing something for me, you don't lose many points for rounding incorrectly, but on my lab you might lose some. It just counts it wrong. It basically usually gives you some sort of message. So my thing would be just pay attention to what it says. On my lab, a lot of times it tells you where to round to, so you don't have to figure that out. Here's our next one. Find the depth of cut X needed for the V-slot shown. Assume the V-slot is symmetric. And so on this, we're basically looking for this X. I'm going to use the pink so it shows up better. And I kind of switched this problem around because it had degrees and minutes, which we're only doing decimal degrees, so we don't work with the degrees and minutes. And so that's why there's kind of a space there. We are going to, let me see if I can draw this part that we're looking at. Okay, so that's the V, and we have to find, right, the depth of the cut, which is going to be this part. I'm going to draw across here. So here's where our right triangle comes in when we draw down the center of this, which I kind of missed. We are going to consider that these are the same length on both sides. And so if they're the same length on both sides, and we're looking for this cut, right, this height here that is in the whatever that thing is over there, the object that we're working with. And so the X is going to be right down the center of that thing, basically. This side is going to be 2.1 inches because it was 4.2. And then 58 degrees divided by 2 is 29 degrees. So this angle is 29 degrees. Okay, so that gives us the information we needed, but we kind of had to work at that. We are using tangent again because we have the side opposite and the adjacent side is the one we're trying to find. All right, that's my opposite. So we'll use that angle of 29 degrees. The tangent of 29 is equal to 2.1 over x. So we multiply on both sides by x. All right. So x times the tangent of 29 is equal to 2.1. So to solve for x, we divide both sides by the tangent of 29. And you can show the division, but you have to write out tangent 29, tangent 29. It's easier just to go directly to this. And I'm fine with you going from this step to this step. Perfectly fine. We divide and find that it is 3.789 inches. And so remember, we're going to go ahead and just round according to this number because I had to change the degrees just to 58 degrees instead of the degrees in minutes that it originally was. So in this case, we just kind of match because 4.200 is 4 significant digits. Okay. So we'll do this example, and then we'll go on to another video. I'll stop this video. Okay, so when we're looking at this, it says find angle A in the figure. So here's angle A. Come back. Just a second. I'm trying to get this to show my... Try this again. We're finding angle A right here. And it tells us that our diameter for the little circle is 3.425 and the diameter of the biggest circle is 5.875. And so really all we need is the radius of the bigger circle. If you'll see, we can use that side. We don't have to do anything special with the other side. So if we take this and divide it by 2, then I get 2.9375, and that is my measure of that side, right, that radius, and that is in inches. And that means that I have got the adjacent side and the hypotenuse, right? I don't have to do anything with the opposite side. That would make it way more complicated, as you can see. So we're going to say cosine of A is equal to my side adjacent, 2.9375. We're dividing that by 8.105. Once again, we are finding the angle measure, so that's going to be the inverse of cosine inverse, or the inverse of the cosine, however you want to say that. Now I went ahead and wrote out the radius just like it was when I divided by 2, which had more digits. The original numbers given were all 4 significant digits, so that means we're going to round our angle to the hundredths place because of the fact that we had 4 significant digits. So 68.75 degrees for that angle measure. All right, I'm going to stop this video and then pick up the rest of the lesson on video 3.